Hi, I just want to make a quick video in response to this question posted on Blackboard. This is a really good one. So, see, in this, I'm going to use this example to talk about this. So, we're given a bag of candy. There are 11 suckers, 6 juicy fruits, and 14 Smarties. You stick your hand in the bag. I'm going to extend the window and draw out 3 candies. If the suckers are A, or if the suckers are A and the juicy fruits are B, then, well, I guess actually A is the event that you pull out exactly one sucker, and B is the event that at least one of the 3 candies is a juicy fruit. Okay, so I'm going to go with that. I'm trying to get down to how do we calculate the probability of A and B, okay, or A intersection B. So let me go here to my board. So just to recap, let's see, we have 11 suckers. Let me change that to the pen. 11 suckers, 6 juicy fruits, and 14 it's Smarties, but I'm going to call it other just so that we can have S, J, and O. Okay, so other. Okay, so we're picking 3 candies. All right, so starting with the probability of A, which A was exactly 1 sucker. All right. First, I want to list out all the different possibilities so I can talk about this, and that'll help us think about later on how to find the probability of A and B. So, by the way, let me go and write that down. So B is at least, oh, sorry. Actually, I should have written that A is exactly 1 sucker. So the probability of A would be the probability of getting exactly 1 sucker. So let me rephrase that. B is at least 1 juicy fruit. Okay. I'm going to use the J for juicy fruit. Okay. So let's see. I could have gotten a sucker, and a sucker. I could have gotten a sucker, and a juicy fruit. Now, I'm not listing off, there are 11 suckers, right? So I'm not listing off this is the first sucker, second sucker, third sucker. So this is, I'm not making a complete list of the of the sample space. Rather, I'm just like listing out all the different possible things that I could get in my hand, right? So I could have gotten a sucker, juicy fruit, sucker, other, sucker, juicy fruit, other. So I think that's all the ways I could have a sucker. Okay, so then next, maybe I have a juicy fruit, sucker, juicy fruit, other. I'm not going to list juicy fruit, sucker, other, because that's already listed here. Sucker, other, sucker, juicy fruit, other, same thing as juicy fruit, sucker, other, right? We don't need to list anything more than once. Just coming up with a complete list of all the different possible things that we would have in our hand. Of course, the order here does not matter. So all we care about is whether or not we have exactly 1 sucker, or how many suckers we have, right? So, okay, so let's see, what else? I might have another, other. I could have other, juicy fruit, other, sucker. I think I've listed them all. If you notice something I missed, okay, we'll talk about that. Hopefully I got them all. All right, so let's talk about what is exactly 1 sucker. So how many times does exactly 1 sucker show up? Let's see. Here, here, and here. Okay, so it shows up when we have sucker, juicy fruit, other, juicy fruit, sucker, other, sucker. Okay, so when I'm doing the probability of A, which is the same thing as saying the probability of exactly one sucker. Okay, really what this is the probability of getting a sucker, juicy fruit, other, right? Or means we would add, because these are disjoint events, right? You can't get both sucker, a juicy fruit, and another, and at the same time get a juicy fruit, sucker. No, these are two different events, right? They're completely disjoint. So since I could get this or I could get that, I would add that, right? And assuming I've listed all the different possibilities, the sum of all of these should add up to 1, right? So, okay. So I'm going to add that to the probability of getting a juicy fruit, sucker. Add that to the probability of getting another sucker. So I get this, or I get this, or I get that. Or. This is the addition rule, mutually exclusive events. All right, so let's see. Sucker, juicy fruit, other. How many different ways can this happen? Well, I have 11 suckers. I'm choosing 1. I have 6 juicy fruits. I'm choosing 1. I have 14 others, and I'm choosing 1. All of that divided by how many pieces of candy do I have? Well, let's see. I have 31 pieces of candy. Is that right? Yeah. 31 pieces of candy, and I'm choosing, how many am I choosing? I'm choosing 3. All right? So this is the number of ways I could have gotten a sucker, a juicy fruit, and another, right? So basically, had I used like subscripts here, this is the first sucker, this is the first juicy fruit, this is the first other, and then if I were to come up with all the different ways I could have gotten this is the second sucker, the first juicy fruit, the first other, third sucker, first juicy fruit, first other, like all the different ways, it would come up to whatever this number comes out to be. Right, this numerator, right, divided by all the different ways I could have rearranged this entire sample space had I used little subscripts, right? It'd be huge. It's the 31, choose 3, okay? So there we go, that's that. Then juicy fruit, sucker. So that'd be how many juicy fruits do I have? I have 6, I'm choosing 2. I have a sucker, 11 suckers, and I'm choosing 1, okay? 31, choose 3. Add this to the probability of getting 2 others, so 14, choose 2, 11, choose 1, divide that by 31, choose 3. All right, great. So, yeah, I could calculate this, I can do this. Now, I know that we talked about in the discussion board that you could have solved this very easily by saying, okay, well, let's see, I have 11 suckers, and I'm getting exactly 1. So 1 sucker, so there's 11, I'm getting exactly 1. And we talked about, well, you could just do this as 20, right? Because there's 20 things that are not suckers, right? 14 plus 6. 20, choose 2, right? And divide this by 31, choose 3, okay? And actually, these things that I just wrote here, this line and this line are exactly the same. Why is that? Well, look, if you you notice that, let me write this. So you notice that 11 choose 1 is common in all 3, right? So 11 choose 1 is common in all 3. And also in the denominator, you have 31 choose 3 in the denominator for all 3. So if you were to pull those out, doing the opposite of the distributive property in algebra, right? So if you were to pull those out, so let me go ahead and erase this. So if I were to pull out 11, choose 1, and then I would have 6, choose 1, times, what do I have left over? So I have 6, choose 1, 14, choose 1, 6, choose 2, 14, choose 2. Go ahead and plug this into a calculator, and let's see, I think I did it in Excel. I think you get 190. You get 190 if you plug that into a calculator, which is the same thing as 20, choose 2. 20, choose 2 is also 190. So, So these are the same, right? So actually, let me show you this in Excel. If you use Excel, use the formula equals combine. That's the same thing as combinations. 20, choose 2. That's 100. Oops. That's 190. And then if you add up 6, choose 1, times 14, choose 1, plus 6, choose 2, plus 14, choose 2, you also get 190. Okay, so these are the same thing. All right, so anyway, the whole point of doing this was not really to talk about how to calculate the probability of A, but really I want to build up to how do we calculate the probability of A and B, or in other words, the probability of A intersection B. That's the same thing. Okay, so well, what does it mean, right? What does A or and B really mean? Which one should I circle here? What events are possible? Well, okay, so at least one juicy fruit is B. At exactly one sucker. So how many meet that criteria? At least one, exactly one. Okay, so yes, this one meets that criteria. At least exactly one sucker, at least one juicy fruit. This one meets that criteria. At least one juicy fruit, exactly one sucker. That's it, right? Yeah, exactly one sucker, at least one juicy fruit. This one does not meet that criteria for this, right? Okay, yeah, so just these two, right? Okay, so yeah, how am I going to calculate this now? So, running out of space. Let me move over to the side. I'll move over here. Okay, so the only two events I have are sucker, juicy fruit, other, juicy fruit, sucker. Okay, again, these are mutually exclusive events, meaning they both cannot happen at the same time. So this would just be the probability of a sucker, juicy fruit, other, and I'm going to add that, right, because this is this one or juicy fruit, suckers. This is an addition rule, mutually exclusive, meaning they both cannot happen at the same time. They both cannot happen at the same time. So I'll just add these two probabilities together, right? And we've already written what those probabilities are down here. It's this piece. It's this piece, right? It's just these two guys, right? So this is just it's just going to be these guys right here. Right? It makes sense, right? So I think that the main problem we were having on the discussion board is really defining what is A, right? A is it's a series of possible different events, right? So maybe listing out all the different possibilities might help us understand this. I hope this video is helpful and that you are able to then calculate this now. It's going to be the answer for what is the probability of A and B would just be these two, right? The probability of getting a sucker, juicy fruit, other, and then you'd add that to the probability of getting the juicy fruit, and a sucker. All right. Please let me know if you have any other questions, and good luck finishing the assignment.